morning everyone, I am Trisha Ulingay from Best After One, and today I will be doing my analytical chemistry lab experiment. But before that, let me prepare things out. This is my laboratory attire. Today, I will be testing the acidity of the household solutions using a homemade pH indicator. And to achieve that, here are the samples and the materials needed in this experiment. So first, I have here the peelings from 3 pieces of eggplant, as you can see. Then second, I have mineral water as our control. And for the apparatus, I prepared a casserole. This is where I will boil the eggplant peelings later on. And then, in adding the amount of control, I have measuring cup, and then I have a sieve to strain, and a teaspoon. I don't have test tubes, I'll just use transparent plastic cups labeled with the sample's common name. So first sample is the calamansi. As you can see, it has a yellow-orange color. Then second, we have vinegar. Then third, we have sugar in water. Then we have table salt. And fifth sample is the vetsin. And the last but not the least is our baking soda. So each sample has a measurement of 1 teaspoon. And in the next one, we will find out what are the reactions when our pH indicator will be added to each sample. Let us proceed in preparing our pH indicator. First, we have here our eggplant peelings, and then our mineral water as our control, and then our casserole. So first, I will add 200 ml of water in this casserole to boil it first. That is 200 ml. Then, when this is boiled, I will add the eggplant peelings, and I will also add tawas to enhance the color of the eggplant skin. Then, after boiling, I will be back and I will show you what are the results or the color of the eggplant extract. Now, I am back. So, here is our eggplant skin extract. As you can see, it has a violet color. So let's see. It has a violet color. Our pH indicator from the eggplant skin extract. And later on, I will add this into each samples, and let's find out what are the chemical reactions or changes in color when this pH indicator will be added. So now, let us start our experiment. Let us see what are the chemical reactions or changes in color when our pH indicator will be added into each of our samples. So first is we have calamansi. You can see it is a bright yellow-orange color. Then I will add our indicator for about 10 ml. So, stop here. And 2. So this is our calamansi. As you can see, that is the color. Then the next one is our vinegar. So our vinegar is white. So let us add 10 it turns into a violet. So let us mix. As you can see, so that is our sample is sugar in water. I will add our indicator. Let us see the color. As you can see, it's a mellow violet. Then the next in line is our table salt. Here is our table salt. We'll mix it. Just add one. Its color. The next in line is our Pepsi. So after 20 minutes of observation, here are the results in color. So first, we have our calamansi. As you can see, from yellow-orange, it turned into a bright red. For the second one is our vinegar. From white, it turned into a lighter violet. The next is our table salt. It's a darker violet, as you see. Then we have our sugar in water. Turn into a lighter violet than our table salt. Then we have our vaccine. As you can see, it has a darker green color. And the last but not the least is our baking soda. So you may wonder why our baking soda turns out like a yellowish color. When I added a pH indicator, its color is yellow-green, but when it was thoroughly mixed, it turned into a yellow color. So this is the color of our baking soda. Now, in order to determine the pH levels of each solution, I have here our pH scale. So I have here the red cabbage pH scale or pH indicator. But first, what is pH? pH is a scale used to measure the acidity of a solution. The H in pH represents the hydrogen ions, and pH is often read as the power of hydrogen. So, pH has a range from 0 to 14, wherein pH of 7 indicates that a solution is neutral, pH less than 7 indicates that the solution is acidic, and pH greater than 7 indicates that the solution is basic or alkaline. So, this pH scale will determine the hydrogen or the hydroxide molecules being contained in a solution. Now, let's talk about what is a pH indicator. So, a pH indicator in chemistry is a chemical detector for hydrogen or hydroxide molecules contained in a solution. So, pH indicator exists as natural dyes and can be determined their pH levels by a change in color. So, the pH indicator that I used earlier in our experiment comes from the extract of the eggplant peelings. Now let's find out what chromophoric group is being contained in the eggplant skin. Eggplant, with the scientific name Solanum milongana, is composed of anthocyanin pigment. Anthocyanin are phenolic compound that is responsible for the purple and the blue-green color of the eggplant extract. So anthocyanin is derived from the flavonoids with basic in structure, and the most often linked to the color purple and the blue-green is the nastamin, which is also contained in the anthocyanin. So the color of the anthocyanin depends on the pH of a solution due to its ionic nature. So this is the basic chemical structure of anthocyanin, the structural formula. Based on the results accumulated from my experiment earlier, so the colors of the eggplant skin extract in aqueous solution, in acidic, and in neutral, and in alkaline or basic are as follows. So in calamansi, which is considered to be acidic, and the vinegar, it has a bright red color with a pH of 2. For vinegar, it has a lighter violet color with a pH of 4. And for the sugar in water and the table soap has a pH of 7, so this is a neutral. And also sugar in water has also a pH of 7. Then for the baking, for our betsin, it has a green color, as you can see. It has a pH of 10. And lastly, we have our baking soda, the yellowish color. It has a pH of 14. In conclusion, eggplant or Solanum milongana, with its extract, is an effective pH indicator in testing the acidity of the household solutions. It is composed of a chromophoric group, anthocyanin pigment. So anthocyanin pigments are responsible for the purple and the blue-green color in its extract. So a pH scale is used in testing the pH level of a solution. It ranges from 0 to 14, in which pH of 7 is the neutral, and pH less than 7 is acidic, and pH greater than 7 are alkaline. So the dissociation of hydrogen and hydroxyl ions determines the level of concentration of a solution. Now I will just give some few tips. First, when you're going to do a laboratory experiment, it is important to wear the appropriate attire. If you don't have a lab gown, just use an apron. Then it is important to use gloves and glasses as well as shoes. In handling the apparatus, always be careful and also be responsible. If you don't have the available glasswares needed, just use the available materials you have at home. For me, I use the plastic cups since I don't have the materials needed, the glasswares needed. And then lastly, always be responsible in your laboratory area before and after your experiment. Clean the laboratory area, and all the chemicals should be properly placed in a storage so that it cannot harm anyone who will use the laboratory area in the next session. So that is for now.